Good morning, dear students. Today I will discuss about the nuclear fission and the fusion reactions. This is the part of Unit 3 and the subject name is Power Plant Engineering. The semester is 7th. This is the outline: nuclear fission, mechanism of the nuclear fission, use of the nuclear fission, advantage and disadvantage of the nuclear fission, requirement of the fusion reactions, use of the nuclear fusion, advantage and disadvantage of the nuclear fusion. This is the fission reaction, the nuclear reaction in which one heavier nucleus, which is slipped up into the two lighter nucleus of the almost equal size, with the release of the huge amount of the energy, that is called a nuclear fission or the atomic fission. There are the two types of the reaction. This is the fusion and the fusion. In the case of the fusion reaction, the one nuclei, lighter nuclei of the almost two nuclei, lighter nuclei of the almost equal size, with the release of huge amount of the energy which are bombarding into the heavy layer nucleus. This is the history. Nuclear fission by the first discover on the December 1. This is the German Otto Hahn, and the explained theoretically in the January 1939 by the Lise Meitner and by the her nephew Otto Robert Frisch. This is the diagram in which the nuclear fission it is clearly shown. This is the incident neutron, which is the bombarding on the fissionable nucleus, and this is the releasing of the energy of the huge amount, and this is splitting of the nucleus of the two part, and after that the neutron is also creating after the bombarding into the this heavy nucleus, and this is the neutron which are the created after the bombarding of the nucleus on the nucleus, heavy nucleus by the small nuclei to light nuclei, producing of the huge amount of the energy, and the fission product which are the clearly shown in this part of the neutron. And this is the continuously chain reaction process. This is the splitting of the nucleus causes the formation of the different, and it is the responsible for the all type of the power generation, like in the nuclear uranium-235, that is the most commonly used the isotopes of the uranium for the nuclear energy productions. So this is the splitting of the nucleus causes the formation of the different small fragments, and these fragments are the about equal to the half to the original mass. Two or the three neutrons and the large amount of the energy also release, and this is the responsible, which is the responsible for the all type of the power generation, like in the nuclear power plant and the nuclear weapons. Uranium is the most common element used in the nuclear fissions. What happened when a neutron, that is the bombarded to the uranium-235, an unstable nucleus of the uranium-236 forms and the undergoes fission splits. The smaller nucleus are the produced, such as the krypton-92 and the barium-144 fission products. Three neutrons, secondary neutrons, are the released to the bombard more uranium-235. The number of the neutrons released determine the success of the chain reactions. In addition to that huge amount of the energy, fission energy released to 35, 92 uranium plus 1 neutron, that is equal to the 236, 92 uranium, and is equal to subsequently equal to the 141, 56 barium plus 92, 36 krypton plus 3, 100 neutron. So this is the chain reaction process. It is the advanced form of the chain reaction process, which are the clearly shown by the after that heavy nucleus, which are the bombarding by the small neutron, which is splitting on the krypton and the barium product, and the number of the neutrons is also emitting from this bombarding processing, and this is also creating all the uranium-235 heavy nucleus another way, and this is subsequently further process are going on. These are the for the three nucleus of the uranium in the different places. This is the 9136 krypton, 142 56 barium, and the subsequent neutron. And subsequently is here is it is representing 9136 krypton, 142 56 barium. This is subsequently the neutron is creating, and here it is same process. This is the chain reaction process where the non-stoppable, it is a process. And the fission is the exothermic. This is the amount of energy which is the release in the nuclear fission can be calculated by the mass defect method. In the fission reaction, that is the total mass of the product, which is the always less than the mass of the reacting nuclei. This is the parent nuclei. This decrease in the mass, which is called a mass defect, which is the converted into the energy. And according to the mass energy relationship, that is the Einstein equation is equal to mc square. Thus, for the nuclear fissions of the two types, this is the continue energy has been calculated to the equal to the 250 mega electron volt, which is shown the below. Interacting particles, product particles. So interactive particle, that is the uranium 23592 is equal to the 235.11750 atomic mass unit, and the product particle, that is the 14156 barium is equal to the 140.95770 AMU atomic mass unit, and the one neutron, which is equal to the 1.00898 atomic mass unit. 9236 krypton is equal to the 91.92640 AMU atomic mass unit. So total 236 is here interacting particles, product particles, that is equal to the total to 35.9991104 atomic mass unit. Loss in mass, mass defect, that is a 236.12648 minus of the 235.91104 is equal to 0.21544 atomic mass unit. Therefore, the energy release per fission of the uranium 235 nucleus, that is equal to the 0.21544 into the 931 mega electron volt is equal to the 200.5 mega electron volt. This is the mechanism of the nuclear fusion liquid drop the model. It is suggested by the Bohr-Wheeler. Since the atomic nucleus has the many similarities with the liquid drop, and the liquid drop has an spherical shape due to the surface tension. If sufficient energy which is applied on the drop to the overcome the force of surface tension, the drop may change its the spherical shape into the elliptical shape. If the external force, which is the large, the elliptical shape may the change into the dumbbell shape and the break into the two portion of the spherical shape. Here the spherical shape, that is called a uranium external force. This is called a neutron, and the energy absorbed by the uranium nucleus to the change from the spherical shape to the critical shape, that is called the threshold energy. And these two parts of the critical shape have the positive charge. They repel from the each other and the separated from the each other, forming to the two spherical shape of the same size. This is the neutron. This is the neutron which is bombarded by the spherical and converted to the sporadial, and after that converted to the dumbbell shape and isolated with the two droplets. This is the use of the nuclear fission. This is the nuclear fission. Here it is a diagram. It is clearly depicted the enormous energy liberated in the nuclear fission, and its occurrence have been used in the atomic bomb. This is the atomic one, fission bomb. Each uranium-235 liberates three neutrons called the secondary neutrons. Each have to be in another uranium-235 nucleus, and that causes the further reactions. Some of the neutrons will escaping into the air, causes the no reaction and the explosions. The size of the uranium-235 nucleus, which is smaller than the critical size, which is called a supercritical. In this condition, the large number of the neutrons were the captured by the uranium-235 nucleus causes the large explosion in the chain reaction. The atomic bomb consists of the thousands of the pieces uranium-235 in the subcritical size. At the time of the explosion, these are the driven together, and these subcritical size of the uranium-235 will combine together and will form one large piece of the supercritical size. Now neutrons from the other sources will strike on this larger pieces of the uranium-235 and causes a rapid chain reaction. This reaction causes a violent explosions with the releasing of the vast amount of the energy. What are the advantages? It helps minimize the environmental pollution. This means they can provide the heat, electricity, and the power to consumers without producing the lots of the carbon dioxide emission. It helps reducing the global warming. Global warming को कम करने का काम करता है. And nuclear fission, there would be the less greenhouse gases, example of the carbon dioxide and the methane in the atmosphere. As a result, the greenhouse effect would be the felt less, and the global warming would be the stopped or at least reduced. It can keep up with the energy demands. Nuclear plants can produce high amount of the nuclear fission energy, and this can be a good thing in today's modern times wherein the demand for the energy is the steadily rising as the more and the more people drive cars. That is the build houses, use electronic devices, and do the energy intensive activities. It can be dangerous for the employee. Disadvantages देखेंगे तो radiation, which is the one of the byproducts of the nuclear fusion, can be harmful to the people if they are exposed to it in large amounts. It can be dangerous for the communities. Communities के लिए भी dangerous है. Wastes by the product pollute the environmental, but will also endanger the lives of the people who live near the disposal sites. And the nuclear plants are also highly volatile. If the accidents occur, they can explode and they affect the surrounding areas and the communities. It has the high initial expenses. Nuclear plants need the specialized equipment and the machinery before they can become fully functional and therefore require the millions of the dollars to be built. The plants also need to put safety measure in the place of the protect their products and the surroundings areas, and these measures can cost a significant amount of the money. The fusion is another process. Nuclear fusion, it is the process by which the multiple nuclei join together to form our heavier nucleus. It is then accomplished by the release or absorption of the energy depending on the mass of the nuclei involved, if it is called thermonuclear reactions. So this is the fusion, another different process in which the number of the heavy nucleus, which are the combined, will take a system and creating the some amount of the energy. When the deuterium, titanium, and the helium, when the deuterium and the titanium, which are makes a combined product, it will releases the in amount of the helium and the energy of the neutron. These are the fusion process in which the all the things are the very clear. Deuterium is the product where and the combined with the titanium, it makes a fusion process in which the amount of energy generated and the neutron which are separately generated. Helium is the new product it is created. So requirement of the fusion reaction process, what are the main requirement for the fusion process? The plasma temperature, it should be of the 100 to 200 million Kelvin. A plasma, which is the macroscopically neutron collection of the charged particle needed to overcome natural positive repulsive forces of the plasma, and the energy confinement. This is the time 4 to 6 seconds. The energy confinement time is a measure of the how long the energy in the plasma, which is the retained before the being lost. Central density is the plasma 1 to 2 into 10 to the power 20 particles per meter cube. It is the minus of, and the larger density needed because of the number of the fusion reaction the per unit volume, which is the roughly proportional to the square of the density. This is the use of the nuclear fusion hydrogen bomb, the principle of the nuclear fusion which is used in the hydrogen bomb, and the temperature required for the purpose of the fusion that is produced by the fusion reaction. The explosions of an atom bomb produces the temperature of the order of 50 million degrees centigrade. A suitable assembly of the deuterium and the titanium, it is arranged at the site of the explosion of the atom bomb. Favorable temperature initiate the fusion of the light nuclei in an uncontrolled manner, and these releases the enormous amount of the heat energy. The fusion reaction, which is in the hydrogen bomb, that is the 1s3 plus the 1s2. It is a mix of the 2 helium of the 4 product plus 0 neutron, taking of the 1 energy plus additional energy. This is the advantage of the nuclear fusion process. Nuclear fusion does not create the harmful wastes. Nuclear fusion only has the creation of the helium as a byproduct. Helium is the that is the non-toxic, and the why not create the same environmental damage that the burning of the fossil fuel creates. It is the incredibly expensive to calculate. The estimated cost of the providing the energy through the nuclear fission, that is just about of the dollar of the 0.03 per kilowatt hour, and this makes it one of the cheapest forms of the energy that humans have ever discovered. There is an infinite of the amount fuel and the nuclear fusion. This is the another advantage. The main ingredient of the nuclear fusion, which is the deuterium, which is the distilled from the ocean water, every other component of the process, which is the either easily found or the easily and made. The end result, it is the infinite amount of the fuel that can be used to create the energy resources for the entire planet. It requires almost as much energy to create the nuclear fusion. To fuse two atoms together, high levels of the heat are required. In order to create this heat, a large energy investment must be made, and this industry still require the innovations. The high levels of the heat that are required to create nuclear fusions means that we need two materials available that can be withstand those temperature to create the energy. With our the current technology, we have no knowledge of a specific material that can be withstand the heat necessary to create the fusion. There are maybe unanticipated consequences to using the nuclear fusion. The fact is that we do not really know much about this form of the energy creation. What would happen to the planet in the 50 years with an increased level of the helium in the atmosphere? Are there health danger that we simply do not know yet and cannot predict? So this is the today lecture. If you have any doubt, please ask me.